Fluid and diet patterns associated with weight cycling and changes in body composition assessed by continuous monitoring throughout a collegiate wrestling season. Department of Nutrition, St. John's University, Collegeville, Minnesota, and Department of Nutrition, College of St. Benedict Ardolph Science Center, Collegeville, Minnesota. Fluid and diet patterns associated with weight cycling and changes in body composition assessed by continuous monitoring throughout a college wrestling season. Journal of Strength and Conditioning Research 24/7, 1763 through 1772, 2010. This study examined the methods used to meet certification weight for wrestling and to measure the changes in body composition during one season of Division III college wrestlers. 9 college wrestlers completed the study. Body composition was analyzed by underwater weighing, UWW, and multi-frequency bioelectrical impedance before and throughout the competitive season. Hydration status was measured by urine osmolality and urine-specific gravity. Nutritional intake was measured for 2 one-week periods, once at the beginning and once near the end of the season. Subjects' fat-free mass, FFM, increased an average of 1.8 kilograms, whereas fat mass, FM, decreased 2.2 kilograms. As indicated by UWW, from the beginning to the end of the season, wrestlers on average cycled their weight 3.4 kilograms, 4.7% of body weight per week. The majority of wrestlers cut weight by reducing calories and restricting fluids starting 2 days before competition. OSM, and body weights on Friday suggested that for wrestlers to achieve the necessary weight loss by dehydration to make weight for a Saturday meet, wrestlers would approach a 5% level of dehydration. No loss in FFM because of weight cycling, WC, was evident to achieve competitive weight. Most wrestlers significantly restricted fluids and caloric intake in the 48 hours before weigh-in. Introduction. The 1997 deaths of 3 collegiate wrestlers within 1 month increased concern about the methods wrestlers use to lose weight. Potentially dangerous techniques are employed to cut weight to a lower weight classification to achieve perceived competitive advantage. In response to these deaths, the National Collegiate Athletic Association, NCAA, implemented a minimum weight MW program in which wrestlers must now be weight certified 1 to 2 hours before competition, which is intended to discourage the excessive amount of weight wrestlers attempt to lose because this reduced time also limits the recovery from extreme weight loss practices. Before the MW program, wrestlers often regained 2.7 to 7.7 kilograms within 18 hours of competition. The MW program appears to have reduced the magnitude of weight changes in the cycles of loss and regain by collegiate wrestlers by weight cycling. WC still continues, and many occur up to 15 to 30 times over a 5-month period. Rapid weight loss is typically accomplished by the restriction of fluids and food that may include heat, saunas, and exercise to induce sweating. The immediate effects may include symptoms of increased heart rate, dizziness, headache, nausea, and decreased anaerobic capacity. But repeated cycles may cause loss of fat-free mass, FFM, and ultimately compromise performance. The purpose of the study was twofold: to quantify the acute weight loss that occurs as college wrestlers prepare for competition, and to examine the patterns of subsequent effects by WC by measuring weight loss, body composition, and nutritional intake over the course of one 16-week session. Methods. The experimental approach to the problem. An observational study was designed to examine the methods used in WC and cutting weight to determine their subsequent effects on body composition and fluid compartments in the body. Body composition was measured at regular intervals throughout the wrestling season along with daily weights. Nutritional intake was determined by food and fluid records, and hydration status was assessed by urine osmolality, OSM, and urine-specific gravity, USG. Multi-frequency bioelectrical impedance, MFBIA, was used to measure body composition, and its accuracy was evaluated by comparing it to hydrodensitometry or underwater weighing, UWW. Subjects: 13 volunteers from a Division III wrestling team provided informed written consent to participate in this study, which was approved by the College of St. Benedict and St. John's University Institutional Review Board before the start of data collection in 2002. Of the 13 subjects who began the study, only 9 subjects completed it because 3 were injured and 1 withdrew from the team for personal reasons. Subjects in this study wrestled in weight classes from 60.3 to 83.5 kilograms. Data were collected on all 13 subjects. Final data analysis was performed for the 9 subjects who were actively competing every week and whose data was complete in all phases of the research. Of the 9 subjects who completed this study, 6 were NCAA Division III national tournament participants, 2 were NCAA All-Americans, and 2 were conference champions. The preseason mean subject profile values include all 13 original subjects, Table 1. Subjects averaged 11.8 years of wrestling experience. A questionnaire completed before the beginning of the season by all 13 volunteers who began the study identified methods the wrestlers used in the past to achieve weight loss, Table 2. Subjects were directly observed daily by one of the researchers who was a student athletic trainer with the team throughout the entire 2-year period of data collection for both the pilot and the primary studies. Even though this researcher worked extensively with the team on a daily basis, all data were coded at the time of collection and reviewed and analyzed at a later date to maintain confidentiality of subjects and preserve blinding procedures. Weight measurements. Baseline measurements of body weight and body composition were conducted approximately 7 weeks before the start of an organized practice schedule. Each subject's dry weight was recorded daily through the season, except Sunday, to the nearest 0.1 kilogram using an electronic scale. Subjects were weighed immediately before practice wearing a t-shirt and shorts but no shoes. The weight of the wrestler apparel was recorded at 0.1 kilogram and subtracted from each subject's weight on non-competition days. The weight measurement for competition days was the certification weight record at the meet. The official weigh-in was conducted with the subjects in the nude. Body composition analysis. Body composition was measured every month throughout the season using MFBIA Body Static Quad Scan, Port Townsend, Douglas, Isle of Man, British Isles, for a total of 6 measurements. The values were compared with 2 UWW measurements taken at the beginning and end of the season. Bioelectrical impedance is a rapid, portable, inexpensive, and non-invasive method to assess body composition, but the accuracy of measurements may be influenced by hydration status. Body Static Quads, 4,000, measured at frequencies of 5, 50, 100, and 2,000 kilohertz, which permits the assessment of both intra- and extracellular fluids, ICFs and ECFs, allowing measures of total body water, ECF, ICF, fat mass, FM, and FFM. Multi-frequency bioelectrical impedance theoretically has the potential to assess changes in fluid compartments and hydration status and is reportedly more accurate and precise than the traditional BIA instruments. Consequently, if changes in hydration status associated with exercise or fluid restriction can be accurately assessed using MFBIA, this tool would be very useful. Body composition measurements were conducted typically on Mondays, 2 days after the last competition, when it was presumed that the subject would be fully rehydrated from the previous attempt by cutting weight, but before the next week weight loss cycle. Body composition measurements were taken after a 2-hour fast and before exercise to avoid the effects of food and liquids in the stomach and the acute increases in body temperature and fluid loss associated with exercise. Urine samples were collected immediately before each body composition measurement to verify hydration status through UOSM and USG. Subjects' underwater weights were measured and repeated until 3 consistent weights were obtained within 0.1 kilogram. Residual lung volumes were estimated using the oxygen dilution technique. Percent body fat, BF percentage, was calculated to use Brosnick's equation. BF percent equals parentheses 4.57 divided by DB minus 4.142 and parentheses times 100. Nutritional intake. The subjects recorded their food and fluid intake for 2 one-week periods. Week 1 was before the first meet, and week 2 preceded the conference meet at the end of the season. Subjects recorded everything they ate and drank, including snacks, nutritional supplements, medications, and alcohol for 7 consecutive days. Subjects were given instructions for recording food and a visual guide for estimating portion sizes and were encouraged to read labels and then record foods as they ate. Rather than relying on memory, subjects were also given reminders and extra opportunities to ask questions of the investigator, who was a student athletic trainer with the team and had their food records briefly checked for completion during the record-keeping period to enhance accuracy. Diets were analyzed using NutriQuest diet analysis program, which estimates the macronutrients and 21 vitamins and minerals for approximately 4,000 foods obtained by the United States Department of Agriculture (USDA) database. The program was written by Dr. Virginia Lee Mermel and produced by McGraw-Hill Publishers. Urine analysis. Hydration status was determined for 5 days during the food recorded period to appreciate the contribution of dehydration to making weight. Urine samples were collected before each practice from Monday through Friday and analyzed using by UOSM and USG. The UOSM is determined by the number of osmotically active particles in the solution, whereas USG is a measure of the density of the solution compared to that of the equal volume of distilled water, and is therefore determined by both the number and size of the particles in the solution. Samples were not collected on Sundays to avoid interfering with the routine of competition days. Urine samples were also collected immediately before each body composition measurement using the MFBIA instrument. Samples were frozen at negative 80 degrees Celsius until the analysis was performed within 8 weeks of collection. Urine analysis of frozen samples was consistent, plus or minus 2 MOSM by UOSM and 0.03 by USG. With fresh urine samples during trial testing indicating the freezing process did not alter the results. Previous research demonstrates stability of urine particles for urine analysis when samples were stored at negative 10 or 70 degrees Celsius for 22 weeks. UOSM and USG were measured using the Fisk model 110 freezing point. Osmometer. Fisk Associates, Norwood, Massachusetts, USA, and the MISCO Digital Fiber Optic Refractometer, MISC, Cleveland, Ohio, USA. Statistical analysis. Standard statistical methods were used for the calculation of means, SD, and a person's product moment correlation coefficient. Statistical significance was set at p is less than or equal to 0.05. Results. Weight loss. Many wrestlers strive to lose weight to wrestle at a classification below their natural body weight. Therefore, body weights and composition were recorded 7 weeks before the first competition to determine baseline values before this anticipated weight loss practice. Subjects lost an average of 5.3% of their initial weight to achieve their wrestling weight class for the first meet and lost an average of 4.7% of their weight each cycle throughout the season. Wrestlers intended to compete on Saturday decreased their weight from Monday to Saturday on average by 3.4 plus or minus 0.3 kilograms. 8 weight loss cycles were measured during the season. A weight loss cycle is defined by a minimum of 5 days between competitions that resulted in a weight gain that had to be subsequently lost to achieve competition weight for the upcoming match. Each weight loss cycle is plotted as a separate line, and the patterns over time are very consistent. Figure 1. There were 65 incidences among the 9 subjects that qualified as WC. Of these 65 cycles, 77.4%, 48 out of 65, reflected a greater loss than 2.3 kilograms, and 24.2%, 15 out of 65 of the cycles recorded of loss more than 4.5 kilograms. The most dramatic change for an individual loss was the loss of 7.6 kilograms, 8.8% of body weight within 4 days, with an average fluctuation of 6.5 kilograms per cycle. The lowest amount of weight loss for one wrestler was an average of 2.3 kilograms per cycle. This amount of weight loss is comparable to the reported practices before the MW program. The MW program may have reduced extreme weight loss practices by some wrestlers, but the current program does not prevent extreme dehydration attempts by all wrestlers. The weight loss recorded by the subjects was also similar to that reported by other investigators at the NCAA Division I level. Body weights and fluid intakes were fairly uniform from Sunday through Wednesday. The fluid intake reported for Thursday was an average 19% less than that mean daily value for Sunday through Wednesday, but the Friday fluid intake on average was 50% less than that mean value for earlier in the week. Figure 2. The average body weight on Thursday was 73.3 kilograms, 72.1 kilograms on Friday, and to achieve target weight, 70.9 kilograms on Saturday. In addition, 1.2 kilograms of weight loss was necessary, which is consistent with previous research. Subjects were asked to report fluid consumption during the 2-hour period after completion to weigh in until competition fluid intake averaged 1.3 liters, range of 0.5 through 2.4 liters of fluid during week 1, and 1.8 liters, range of 0.2 through 3.0 liters of fluid during week 2, both of which exceeded the total intake from the previous day. Average U awesome steadily increased from Tuesday to Friday during the first week, with a significant change occurring between Thursday and Friday. Figure 3. U awesome and USG were highly correlated, R2 equals 0.938, which was consistent with but slightly lower than the previous research. Figure 4. Body composition compared with UWW, MFBIA gave parallel but consistently lower mean changes for FFM and FM. Subjects' significant P is less than 0.05 decreased their FM by 2.2 kilograms as measured by UWW and recorded as a non-significant decrease of 0.9 kilograms by MFBIA from the beginning to the end of the season. The changes in BF percent represented an average decrease of 2.9 plus or minus 2.1% estimated by the UWW and 1.1 plus or minus 0.7% by the MFBIA fat-free mass. Increased significantly by UWW, 1.8 plus or minus 1.5 kilograms, P is less than 0.05, whereas MFBIA revealed a non-significant increase in FFM by 0.3 kilograms. The urine samples taken before body composition measurements indicated only 19% of subjects were well hydrated, defined as USG less than 1.010 corresponding to USOM less than 410 M awesome in figure 4, and 14% were significantly dehydrated, defined by a USG greater than or equal to 1.021 corresponding to USOM greater than 860 M awesome. The 5-day USOM and USG patterns also suggested that most wrestlers were less than optimally hydrated at the beginning of the week, and some were perhaps chronically dehydrated. This extended dehydration may have affected the results obtained by the MFBIA compared with the UWW, despite the claims that MFBIA is able to assess for hydration status. Dietary intake. The average self-reported caloric consumption during the first week of diet and fluid records was 2,000 kcals, ranging from 924 kcal the day before and 4,082 kcal the day of the competition. And during the second week was 2,387 kcals, ranging from 874 kcals the day before and 3,361 kcals the day of competition. The average daily protein intake for week 1 was 68.5 plus or minus 15.6 grams protein, and the 87 plus or minus 20.7 for week 2. The overall mean protein intake was 1.0 grams per kilogram of body weight. All but 2 subjects consumed at least an average of 0.7 grams per kilogram of protein. The lowest was 0.53 grams per kilogram. Carbohydrate intake for the first week was 334 plus or minus 107 grams, and for the second week was 343 plus or minus 90 grams. Fat intake for the week was 50 plus or minus 15 grams, and week 2 70.5 plus or minus 21.7. Energy expenditures for each subject were estimated using the Brosnick-Grund. For each subject were estimated using the Brosnick-Grund formula to calculate basal metabolic rate (BMR), which was multiplied by an activity factor of 1.5 to determine total energy expenditure. Subject's average BMR was estimated to be 2,064 kcals, and the average total daily energy expenditure was estimated at approximately 3,140 kcals,
ranged 2,706 through 3,476 kcals. The mean U, OSM, and USG for urine samples taken before each MFBIA measurement were at or below 860 m-OSM and USG less than or equal to 1.021 on all occasions, signifying minimum dehydration. The overall mean U-OSM was 787 plus or minus 76 m-OSM, and USG was 1.019 plus or minus 0.94. Although the range is large, 82 to 1,158 m-OSM, USG 1.001 to 1.031, indicating that some wrestlers were in fact significantly dehydrated at the time of measurement. Thermal dehydration disrupts the assumptions that are used to determine body composition by biological impedance. Subjects restricted fluids to achieve their target body weight, but some may have also used other techniques to induce sweating, thus changing their electroconductivity. The details on how subjects made weight during the season were not solicited, rather information about weight loss methods used prior seasons were gathered. Table 2. Comparative tests with the MFBIA relative to other measures of body composition will be continued. Discussion. Subjects in the study lost an average of 5.3% of their preseason weight to achieve their desired weight class, and 4.7% of their weight with each WC throughout the season, which is comparable to other reports in the literature. Subjects in practice lost more weight per weight loss cycle than they predicted based on the preseason survey. On the preseason survey, only 63%, 8 out of 15 subjects indicated a typical weight loss of more than 2.3 kilograms per cycle. However, during the study, all of the subjects experienced an average weight loss greater than or equal to 2.3 kilograms. Only 8%, 1 out of 13, reported in this survey a typical weight loss of more than 4.5 kilograms each cycle. But 33%, 3 out of 9 subjects, average weight loss was more than this amount. The individual lost more than 7 kilograms on 4 occasions, and each time 80% of the loss was accomplished between Thursday and Saturday. Furthermore, it appears that many subjects feel that fluctuations of 2.3 kilograms constitute maintaining a consistent weight. Because 69% of subjects reported in the preseason survey they maintain a consistent weight throughout the season, and 62% reported variations at more than 2.3 kilograms. Wrestlers in the study reported that their typical methods for losing weight were a combination of exercise, 92%, caloric restriction, 92%, and dehydration, 77%. These approaches for weight loss are commonly practiced among wrestlers. Less commonly used techniques in the study and others include the use of diuretics, laxatives, spitting, fasting, and forced vomiting. 2 individuals in the study fasted for more than 24 hours, and 1 individual reported having only 0.18 liters of fluid during a 24-hour period in order to make weight during the weeks the diet was recorded. The weight loss cycle for these subjects typically began on Thursday. Body weights on average remained fairly steady from Monday through Thursday, with most of the weight loss accomplished in the 48 hours before weigh-in. The change in body weight closely paralleled the change in fluid and calorie intake. Subjects on average consumed less than 1.34 liters on the day before competition. After weigh-ins, the average fluid content before wrestling was 1.55 liters, but the total fluid consumed for the day was 4.9 liters, which does not reach the recommended intake. A total of 6.5 liters might be recommended, assuming the following: practice 3.5 liters 2 hours before, and 3.3 liters 20 minutes before exercise. Practice 2 liters per 2-hour practice. Post-practice, if weight is lost during practice, replace the fluids, totaling 125 through 150% times the number of kilograms lost, and baseline 3.7 liters. If the complete weight loss was accomplished via dehydration, this would represent as much as an average of 4.7% level of dehydration per wrestler, which is considered serious dehydration. Furthermore, 4.7% is the mean value. Consequently, some wrestlers were more seriously dehydrated. The subjects who lost more than 7 kilograms on multiple occasions had a loss of more than 8.6 of his body weight during those 4 cycles, putting him at severe risk for heart-related illness. Subjects' self-reported caloric intake also sharply decreased during the last 48 hours before weigh-in. The average intake for Thursday was 1,526 and 900 kcals on Friday. The average intake on Saturday post-weigh-in was 3,722 kcals. The average self-reported daily caloric intake, 2,192 kcals, is below the estimated daily caloric requirements, 3,140 kcals, but is similar to the values reported by others for collegiate wrestlers engaging in cutting weight. An energy deficit of 1,000 kcals is expected to result in a weight loss of slightly less than 1 kilogram per week. However, accumulating weight loss did not occur in these subjects over the course of the season. In fact, weight fluctuations, loss, and subsequent regain remained surprisingly steady from one cycle to another. Individuals cannot consume calories substantially below their estimated requirements without adverse effects on body weight and composition. However, body composition over the course of the season did not appear to be undesirably affected. In fact, FFM increased slightly in this study. One possible explanation that there is be as much as 35 through 40% margin of error in self-reported foods recorded even with proper training and motivated subjects. Another explanation is that the WC lowers the BMR and increases food efficiency. Horsell and Melby measured a 17% decrease in BMR in collegiate wrestlers who lost weight during the season. The depressed BMR may be an adaptive process to conserve energy by decreasing protein metabolism. Steam found that a 14% lower mean BMR in wrestlers who cycle their weight. Consequently, energy requirements during the season may be lower than formulas predicted, and this effect appears to be greatest in those who are well below their natural weight or who cycle their weight frequently. The decrease in BMR may depend on changes in body composition, the amount of weight loss, and the effects of acute dehydration. Both the amount of weight loss per cycle and the number of cycles were similar to what was commonly reported by other investigators. It appears that most subjects functioned at a minimal level of dehydration at baseline and accomplished further weight loss by rapidly through dehydration. This practice of achieving rapid weight loss through dehydration may have minimized the impact on lean body mass. BMR was not measured in the study. However, if BMR does decline, energy expenditures would be overestimated. Likewise, energy expenditures independent of training sessions, that is, during the rest of the day, may reduce during weight loss cycles, which would also reduce the total energy expenditure below the predicted values. The variations in weight loss that occur during each cycle and the caloric and fluid intakes are more easily studied when averages are compared, but this may obscure some observations. The mean caloric intake was approximately 950 kcals below the estimated energy needs, but individually caloric intakes range from 0 to 6,130 kcals. Some wrestlers maintained their weight close to their target, whereas others accomplished a more dramatic weight loss each cycle to make weight. Furthermore, the subsequently lower caloric and fluid intakes are limited to a short period, typically 48 hours, suggesting that fluid loss, as opposed to FFM, accounts for the weight change. Self-reported diet records are associated with some error. Even dietitians may underestimate their own intakes by about 10%. The mere act of recording food may alter one's intake, and not all foods consumed are included in the database, requiring substitute foods to be chosen during the analysis. Furthermore, these diet records represent only 2 weeks out of a long season and may not accurately reflect the true average intake for these subjects. However, the subjects were highly motivated to learn more about their diets, and methods to encourage accurate food records were employed. Frequent contact with subjects to monitor the record-keeping process and answer questions would be reduced unintentional errors in records. Carbohydrates provided an average 62% of calories, protein 13, and fat 25. The results of the dietary analysis in the current study indicate a diet that is higher in carbohydrate and lower in fat than reported by others. The higher carbohydrate intake may protect anaerobic performance while on a weight-reducing diet. The average carbohydrate intake during the 2 weeks of diet record was 338 plus or minus 97 grams, or about 4.7 grams per kilogram. On the Friday, dropped to 1.9 grams per kilogram carbohydrate consumed, necessarily to optimize and restore glycogen stores in a minimum of 5 grams of carbohydrate per kilogram body weight per day for athletes like lecturers, and even higher for male endurance athletes. A 75 kilogram wrestler, approximately the mean weight of the subjects, would require 375 grams, 75 kilograms times 5 grams of carbohydrate per day before competition based on recommended instructions, but at this rate of 1.9 grams per kilogram, only 143 would be consumed. It is not known on average intake of An average intake of 4.5 grams per kilogram of carbohydrate is sufficient for adequate glycogen stores to support wrestling. However, the very low consumption in the 48 hours preceding competitions is expected to deplete stores. The calories consumed on Friday, in fact, account for only 5.8% of the total calories for the entire week, making it impossible to fill glycogen stores. Continuous monitoring of body composition using NFBIA can accurately reflect trends in body composition and can have a practical tool to track changes in lean body mass. However, the absolute values obtained by NFBIA may be slightly inaccurate, as the population may be chronically dehydrated. Glycogen is the primary fuel for wrestling, as evidenced in a significant reduction in pre- and post-muscle glycogen levels after wrestling bouts. The impact of weight loss on performance is related to diet composition and total energy intake. Muscle glycogen levels are significantly depleted after weight loss procedures typically used by wrestlers. Before the MW rules, wrestlers commonly had 12 to 18 hours to refuel after weigh-ins before competition. But even this amount of time did not completely replace stores. The process for complete rehydration and replenishment of glycogen stores may require 24 to 48 hours. The MW practice of weighing in 1 to 2 hours before the match drastically reduces the potential to rehydrate and replace glycogen stores. Wrestlers in this study consumed an average of 1 gram of protein per kilogram body weight per day, which is comparable to levels of protein intake reported by others. This level of protein intake, however, is considered suboptimal for weight-restricting athletes who are estimated to need between 1.4 and 1.8 grams of protein per kilogram. If protein intake was optimal, the gains in FFM that occurred during the season may have been even greater. The present investigation suggests that weight fluctuations in these subjects did not result in loss of FFM during the wrestling season. In fact, a slight increase in FFM and a decrease in FM occurred in the present study, although somewhat surprising given the reported caloric intake. These findings are consistent with previous research. Wrestlers who cycle their weight while regularly exercising did not lose FFM over the season. In fact, they gained modest amounts of FFM while losing FM from the beginning of the season to the peak season. Individuals who strength train while restricting caloric movement preserve FFM by a release of testosterone accompanying acute exercise. The subjects in the present study performed resistance training about twice a week as part of the conditioning with the team, and 9 of the 13 subjects who began the study reported they performed independent weight training during the season. The restriction of fluids alone may hinder performance even without the loss of muscle mass. Friday fluid intake accounted for 7.3% of the week's total fluid. Subjects were still more than 1 kilogram away from the competition weight on Friday. U-Awesome averaged 916 and Awesome suggested a level of dehydration of about 3%. At weigh-in, the level of dehydration would be about 4 to 4.5% to achieve the additional weight loss. Rapid weight loss achieved through dehydration can adversely affect the cardiovascular system and the nervous system, impair renal and thermoregulatory functions, alter electrolyte balance, and decrease muscular strength and endurance, all of which will adversely affect performance and can possibly lead to serious health consequences. The volume of fluid consumed by wrestlers from weigh-in until they wrestled was between 1.3 and 1.8 liters of fluid. This volume is insufficient to correct the fluid deficit. A level of dehydration of just 2 through 2.5% can significantly compromise the ability to perform high-intensity exercise. Furthermore, the negative effects of dehydration will occur at a lower level of exercise intensity if the athlete is not well hydrated at the onset of exercise. Assuming the entire loss of weight is because of fluid loss from Wednesday to Saturday, this represents an average of 4.2% loss in body weight during this time period and a 4.7% loss in weight throughout the entire week. Because complete rehydration and restoration of glycogen takes 24 through 48 hours, and wrestlers have less than 2 hours after weighing in before competition, they are not optimally prepared for maximum performance. Practical applications. The MW program has not completely eliminated the dangerous practice of making weight by dehydration. Once wrestlers establish their certifying weight at the beginning of the season, they are restricted in how much they can reduce their weight each week. However, the MW program does not track weight gain and loss, and large fluctuations can occur. Individuals should be monitored after achieving a weight class to encourage wrestlers to minimize the magnitude of their WC, especially because some wrestlers may lose weight than they anticipate as garnered by their preseason surveys compared with wrestlers' actual weight loss. The wrestlers in this study were able to achieve their goal weight primarily by dehydration and caloric restriction beginning 3 days before competition. The average carbohydrate intake on Friday of 1.9 grams per kilogram was far below the recommended minimum intake of 5 grams of carbohydrate per kilogram for athletes. Wrestling is an anaerobic sport that uses glycogen as a primary fuel. Wrestlers who are restricting fluid and fasting to make weight will not have adequate glycogen stores and will be dehydrated, both leading to less than optimal performance. Even with the increased awareness of the implication of dehydration, wrestlers are still reluctant to change their routine of wrestling at lower body weights because they believe this practice gives them a competitive advantage. Wrestlers and their coaches should be given more information from their strength and conditioning coaches and athletic trainers about the benefits of wrestling in a well-hydrated state with the adequate carbohydrate intake. This instruction should include the physiological consequences of dehydration, headaches, dizziness, higher perceived exertion, and increased heart rate that lead to decreased performance and an increased risk of heat-related illness. In addition, athletes should be encouraged to maintain an adequate diet, 5 grams of carbohydrate per kilogram, to help maintain optimum glycogen stores. The MW rules reduced, but did not completely eliminate risk associated with making weight through dehydration, because weight loss practices of wrestlers are frequently not monitored during the season. The only way to completely eliminate the practice of making weight through dehydration is to conduct urine testing at the time wrestlers weigh in for a competition. A safe level of dehydration should be established as a minimum to be allowed to wrestle. Wrestlers can safely, although not optimally, compete at a dehydration level of less than 3%, U-SG less than 1.021, U-Awesome less than 815. Figure 4. Wrestlers that exceed these values, being more dehydrated, should not be permitted to wrestle even if they successfully make weight. A urine analysis at the time of weigh-in would level the playing field and could ultimately prevent the risk practices that are still used by some wrestlers. Acknowledgements. This study was supported by an undergraduate student research grant from the College of St. Benedict and St. John's University Undergraduate Research Foundation. Special thanks to Coach John Eldon, St. John's University, for his team's cooperation, and Dr. Dave Bacharach, Human Performance Laboratory, St. Cloud State University, for use of the underwater weighing facility, and also to Dr. Michael Gass, St. John's University, for statistical consulting.